In the last section, we made a couple of different files and folders inside of our Ethereum directory. We're now going to start working on our compile.js file. Before we start writing any code in here, I want to remind you how we did things previously back on our lottery project. So back on the lottery project, we read in the lottery file with read file sync right here. We then took the contents of that, fed it into the Solidity compiler, and then we eventually exported just the lottery contract from this file. There was a very big downside to this approach right here. And the downside was that every single time we started up our project, either to run some code or run our tests or whatever it was, we always had to recompile the entire contract. So this time around, I don't really want to wait those 3, 4, 5 seconds for our contract to start up. Instead, I want to compile our contract one time, write the output to a new file inside of our project, and then access that compiled version. So in other words, rather than compiling every time we start our project up, I want to compile one time and write the output to a file that we can then read in the future. So with that in mind, our compile file is going to look a little different than it did previously. There are going to be a fair number of steps that we're going to go through in here to implement this new compile flow. So let's first walk through those steps, and then we'll start adding some code to the compile file. Now, the first thing I want you to be aware of here is that we have one single campaign file contract, but inside there we have two separate actual contracts. When we feed this one file into the Solidity compiler, we're going to eventually spit out two separate files. So one file is going to contain the compiled campaign, and the other is going to contain the compiled campaign factory. So we want to take both these output files and save them both to our project directory somewhere. And the real question then is, hey, where are we going to actually save them to? So here's a diagram with our Ethereum folder. Inside there, we have the contracts folder and we have the compile.js file. I'm going to propose that maybe we should make a new folder inside of the Ethereum one. And maybe we should call that something like build. And we can place all of our compiled contracts into this build folder. Then we can put some logic together inside the compile.js file that goes through these steps right here. So anytime we run this compile script, we'll go through these steps. So let's walk through them very slowly, or very quickly, either one. So the first thing we're going to do is to delete the entire build folder from this compile.js script. This might be a little bit mysterious right here, but remember, the idea is that we should only be running our compile script one time now. And then we should be able to run our application as many times as we wish without having to wait for the Solidity compiler to run again. So if we ever run the compile script more than one time in a row, that definitely probably means that we are making some very active changes to our contract. Like we are changing our contract directory or the contracts that sit inside this folder. So if we are changing our contracts, we very likely want to throw away all the previous stuff that we had compiled before. We don't want any old or outdated code sitting around. So the first thing we're going to do inside this compile.js file is to delete that entire build folder if it exists. After that, we'll reach into the contracts directory and we'll read the contents of the campaign.sol file. So this is very similar to what we were doing before when we were reading the contents of the lottery directory, or excuse me, the lottery file. Next, we will compile both the contracts inside that file with the Solidity compiler. And as we just said a moment ago, the output of that is going to be the compiled campaign and the compiled campaign factory. And these are two separate objects, two separate files that we want to deal with. So we're going to take both those outputs and write them both to the build directory as JSON files. Then anytime in the future when we need to access the ABI, remember that's the interface, or the bytecode of our contracts, we can read them from this build directory without having to actually recompile any of our contracts. Okay, so that's the idea. Let's take a pause, come back to the next section, and we're going to start to integrate this script into our project.